So that should be very familiar from beginning algebra, all that square root stuff. What about the nth root? You may or may not have talked about this before. The number c, so this is in parallel with the last definition of a square root. The number c is an nth root of a if and only if, what do you think has to be true? N is some counting number. So if and only if we can raise c to whatever n is and get a. So instead of saying c squared equals a, it's c to the n equals a. If that's true, then c is an nth root of a. In symbols, we would say the nth root. When you see that symbolism, we would actually say the nth root. As well, I kind of already stated that. That symbol, the nth root, denotes the principal nth root of a. N is called the index. Okay, it is possible, depending on the n, that the nth root of a could be negative. When n is an even number like 2, 4, 6, 8, the principal nth root of a is the positive root. But when n is odd, it doesn't necessarily have to be positive. And you'll see what I mean as we go on. So that's why sometimes we use jargon and it seems like there's no reason. Why not, you might have been thinking earlier, why not just say positive? Why write principal? Well, because as you'll see, in certain situations, principal does not necessarily mean positive. So simplify, how would we say that first symbolism, that radical with the 3 there of 8? Cubed root of 8. The third root of 8. N is equal to 3 in this case, in other words. So what is the third root of 8? 2. And we can't say negative 2, can we? Because if you cube negative 2, you get negative 8, don't you? So there actually is only one. And of course, when we use that symbolism, the radical symbol anyway, we're expecting to get a single answer anyway. So why is this true according to the definition? This is true since you can do what with 2? You can take it to the third power and get what's underneath the radical, right? So the cubed root of 8 is 2, since 2 cubed equals 8. That's what the definition says has to be true. Okay, what about the fourth root of 81? 3, yeah, so that's 3, and then you could say since what? 3 to the 4th equals 81. What's n in this case? N is 4. By the way, n is called the index. Okay, what would the cubed root, in part C, what would the cubed root of negative 8 be? Oh, hold on, I forgot a part D over here. Let me fix that. Okay. In part D, what would the cubed root of negative 8 be? In part C, what would the cubed root of negative 8 be? Negative 2. Why? Since?
Because negative 2 cubed is negative 8.
Yeah. If you take negative 2 and cube it, that means negative 2 times negative 2 times negative 2. You get negative 8, right? Because if you take a negative number times itself 3 times, or 3 negative numbers multiplied together, you get a negative number. So this is the example I was talking about earlier. The principal cubed root of negative 8 is a negative number, negative 2. Okay, so principal doesn't always mean positive when the index is odd. And the guy underneath the radical, by the way, we call the guy underneath the radical the radicand. Sounds like a dance you do, right? Do the radicand. But no, it's the number underneath the radical. When the radicand is negative and the index n is odd, then the principal root is going to be negative. Okay, in part D then, what's the fourth root of negative 2 to the 4th power? Some people might say negative 2, right? I wouldn't write this down. Using this sort of justification, what statement has to be true? It would have to be negative 2 to what power? Since negative 2 to the 4th power equals 16? Yeah. Okay, it's true, right? That statement is true, right? But there's another number that satisfies that statement. I like that. Regular 2. Just 2, right? So this is why I said don't write it down. Even though this is true, there's another number that satisfies this statement, and it's 2. Right? Because if you think about it, this guy, negative 2 to the 4th underneath the radical is 16. So really we're asking, what is the principal 4th root of 16? Oh, aren't we going to take the positive one? Yeah. So that's why I said don't write it down. We're actually going to take, when the index is even, we're going to take the positive root. And then the reasoning here, the 4th root of negative 2 to the 4th is positive 2. The principal 4th root of negative 2 to the 4th is positive 2, since negative 2 to the 4th power equals 16. Okay? Yeah, it's a little bit disturbing, isn't it? So what's the rule then in general? Okay, we want the nth root of a to the n to be just a, don't we? That's why you guys said negative 2 up here when we were taking the 4th root of negative 2 to the 4th. Because it works with other ones, right? It works, if you think about it, the cubed root of 8 up here is the cubed root of 2 cubed. It's like the cubed root knocks out the power of 2, or knocks out the power of 3 rather, and you just get 2 left over. And if you think about this one, it's the 4th root of 81 is the 4th root of 3 to the 4th. It's like the 4th root knocks out the 4th power, and you're just left with 3, right? And so we really would like the nth root of a to the n to equal a, but what ruins that? This last example ruins that. Do you see that? This last example, according to that rule, if that were the rule, you should have got negative 2 here. But that's not what we want it to be for various reasons. We want it to be the principal or the positive root when given a choice. So what's the rule then? Well, the rule, if n is even, as in the last example, is to take the absolute value of that base a. The nth root of a to the n is the absolute value of a, which works, right, with that last example. If you take, a is negative 2 in this case. If you take the absolute value of negative 2, then you get the answer we wanted. So a little bit confusing there. A little bit confusing. I'll say more about that as we go through some of the examples. Now, the problem doesn't exist if n is odd. So if n is odd, then the nth root of a to the n does turn out just to be a. And you can see that with the second to last example, right? You can think of the cubed root of negative 8 as the cubed root of negative 2 cubed. So it is like this cubed root knocks out this power of 3, and you're just left with negative 2, which was the answer we wanted. And it was the answer we got. So n is odd, like 3 or 5 or 7, no problem. The nth root of a to the n is a. It's only when n is even and you're raising a radicand, a negative radicand to an even power, that you have to use those absolute values.